Section 11.8, Graphing Linear Inequalities. Once again, vocabulary. Jot those down, put them in your notes, and let's kind of jump into this. Let's kind of slide down past this one. And let's say that we want to graph an inequality. Now, we did, everything till now has been lines, so let's say that we've got something that, it's not going to be just a line. We've got y is less than x plus 1. We've got a bigger area. And we did inequalities in the last chapter, so we're kind of bringing those back up again. When you do this, the first thing that you want to do when you're graphing inequalities is you want to decide what really the line is going to be, and we're going to find the line. And the easiest way is to just get rid of the inequality and make it into an equal sign. So I'm going to plot this line, y equals x plus 1. One side of the line is going to fit into this equation, the other side isn't, and I'll figure that out later. Then the other thing I need to determine right away is this line is the line going to be included? And the way that line would be included is if it is a greater than, equal to, or less than or equal to symbol, then I'm going to include that line. If it's just a greater than or less than, how about less than or greater than, then it's going to be simply, it's not going to be included. And when I do that, I'm going to use a dotted line or dash line. So for instance, in this first one here that I'm doing, as you look at it, it says y is less than x plus 1. So that's going to tell me, hey, that's going to be a dotted line. So now I'm going to forget this part of it. I'm going to work with this instead. That's easier. But I'm going to know that I'm going to do it as a dotted line. So let's kind of go. I don't like, there's not enough room for me to work here. So let's go over to this one. And let's say that this is what I'm doing. Y is less than x plus 1. And so once again, the easiest thing is just consider this to be y equals x plus 1 and plot this line. Well, okay, so y-intercept 1, 1, and slope is 1. So up 1 over 1. So everything should be going through corners of boxes right here. So I've got that line that way. I've got this line. Do not try to analyze how unstraight my line is. Okay, so there's my line, somewhat straight. And when I look at that now, I have to now determine well, actually, let's go back. All right, so now I've plotted the line. So now I know that, I better not add that in there. I have to determine if it's going to be a dotted line or a whole line. Well, since there's no equal to sign, it is going to be a dotted line, or dash. So that is way too big. Well, let's just go back. We'll redo this line, and we'll just put it in dotted now. Dot, 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 dot. Not the most perfect line. Yours, of course, will look better. But that line is not actually included. Now, what I need to do is determine which side of the graph am I going to include this side of the graph or this side of the graph in here. And the easiest way is to take any point and put it in. And the easiest point almost always is to use the point 0, 0. So I'm going to use that point 0, 0. I'm going to plug it in. So put in 0 for x, 0 for y. All right, and see if this is a true statement. 0 is less than 1. Is that true? Yeah, of course it is. If it's true, then the side 0, 0 is included, and so I now graph this side. This is what I'm including in my, you shade this, and of course your shading will look much better than mine. I am on a smartboard that does not understand how to shade. So that would be included in that particular graph. All right, let's do another one. Let's try y is greater than or equal to 1/2 x plus 3. Once again, easiest thing, just start with graph the normal y equals 1/2 x plus 3. Start with that. Y-intercept is 3. 1, 2, 3, right there. Slope is 1/2, up 1 over 2, up 1 over 2. There's my graph. It's going to look like this. Beautiful. And I didn't check. Oh yeah, the equals is in there, so good, because now my light graph is going to be a whole line instead of a dotted line. And then just figure out a point. So once again, 0, 0 is the easiest one. So put in 0, 0, plus 3. 1/2 times 0 is 0, of course, you know that. And 0. So is 0 greater than or equal to 3? Nope. So that means I graph this side of the equation, or the line. It looks beautiful. Oh, I'm an artist there. So there's my second one. All right, let's try this one. This one's a little more difficult because you got all the x's and y's on one side. We might have to do a little bit of work with that. So once again, remember, we want it to end up in this kind of form, y equals mx plus b. So I'm going to keep the y, and I'm going to get rid of the x. So minus 3x and minus, well, oops, that is not an eraser. Minus 3x over here. Add these together. This gets me y less than or equal to 12 minus 3x. I don't like it in that form, so I'm going to switch this part of it, put that first, so I'm going to get y less, I'm jumping up above here, y less than or equal to negative 3x plus 12. And to plot, think of it as simply y equals negative 3x plus 12. Since this was greater than or equal to, my line is going to be a whole line, not a dotted line. Here's my y-intercept. I do not believe my graph goes that high, so we're going to have to expand this guy here a little bit. Hang on a second. Okay, bring this down. Okay, let's think. 1, 2, 3, 4, 6, 7, 8, 9, 10. That's what I thought. 11, 12. So there's 12. Okay, so my point, my y-intercept is right up there, and it goes negative 3, so that means negative 3 over 1. So to the left, actually to down 3, I can't even think. Down 3, 1, 2, 3, and over 1. There we go. And let's just keep going so I get a little bit more on my graph. Down 3, over 1. So I'm going to get a graph that looks something like this. And then I got to figure out, okay, going back to my original, or at least part with the inequality in it, and I put in zeros because those are easy. 0 less than or equal to 0 plus 12. Is 0 less than 12? Yeah, so the side with the 0, 0 on it, the origin, would be included. So all of this gets included in my graph, so the graph should look something like that when I'm all done. All right, so let's use graphing and inequality and use it to solve a problem. So here we go. At the local fair, rides cost $3, games cost $1. Gloria has $12 to spend on the rides and games, and how can she spend her money? And so if we think about it, we've got $3 per ride, $1 per game, and she has at most $12 that she's going to spend. So we're going to do this on, let's go back over to the notebook here. And my this graph, the way this is set up, is not going to be big enough, so I'm going to actually redo my lines. Let's have this be my y-axis and this be my x-axis, and hopefully the black in there from the other stuff doesn't confuse you too much here as we go through this. So just ignore that other black line. It's not really there. And so let's take this, what we've got. We've got 3x plus 1y less than or equal to 12. And the first thing we need to do is kind of rearrange this so that we have it in y equals mx plus b form so that we can graph it. So let's get rid of the 3x over here, 3x, and do 3x over here. So we would get y is less than or equal to 12 minus 3x. And I don't like it that way. I want to switch this around in front of there. So I'm going to say y is less than or equal to negative 3x plus 12. So I can do that. And now I have it in the form of y equals mx plus b. Notice that we do have less than or equal to, so my line is going to be a straight line, or not a dotted line, it's going to be a whole line. And so let's take a look. Y-intercept is 12, and so if this is my 0, 0 point, 0, 0, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my y-intercept form. And the slope is -3, so therefore it's -3 over 1. So the change in y over change in x. And so I am going to go down 3, because y values are up and down. 1, 2, 3, and over 1. So there's my first one. And I'm just going to do this a couple times, give me a little bit better, because I can't draw straight on here anyway. So down 3 over 1, down 3 over 1. So now I got a pretty good line. You wouldn't necessarily have to do that. You got a ruler, and I still can't draw a straight line. All right, so now we want to figure out which side of that line would we fill in. Are we going to fill in above the line? Are we going to fill in below the line? Which side are we going to fill in? So let's go back to this equation here and put in some zeros. So we get 0 less than or equal to -3 times 0, which is 0, plus 12. So 0 less than or equal to 12. Is that true? Sure. So the side with 0, 0 works. But now there's one thing to think about. Because we're talking about real example here, this is a person with money, or they're riding the rides, they're using real money. We can't have negative rides. You can't have negative games, and you don't have negative money. So we're not going to have any of these things below the axis. But we would have all of these. It would include, she could not spend anything, so it would include 0, 0 if she didn't spend anything. But my graph is going to look something like this when I'm really done with what she's going to get. It's going to be kind of like that. And of course, once again, the other thing to think about is they're always going to be whole numbers, because she's either going to buy a ride that costs $3, not $2.50 or anything else, or a game that's $1. So, not every single place in there is actually going to work. Technically, just the whole numbers anywhere in there would work for this particular graph. So just something to keep in mind as you're looking at that one. All right, let's just do they don't have any example problems for you to do there, so I do want you to do some. So I'd like you to graph these right here. So why don't you graph those inequalities and then show them to me, and just to make sure that you know what you're doing.